1.01, the number line. Our first vocabulary term is rational numbers. Rational numbers can be written as a fraction, like a over b, as long as, we need to add this in, b is not equal to 0, because I'm not allowed to divide by 0. That would be undefined. We can also have a terminating or repeating decimal. And now for examples. An easy example of a rational number would be like 1/3. That's a fraction. We look at that, we all know it's a fraction. But I could also write it as a decimal. 1/3 as a decimal is 0.3333. We know the threes go on and on forever, which means I could write it as 0.3 repeating. That would be a repeating decimal. So we have an example of a repeating decimal here. We have an example of a fraction. Another example would be square root of 25. Because the square root of 25 is equal to 5, and 5 over 1 is a fraction. I can take any integer, put it over 1, make it a fraction. -7 would be an example. Again, I can take any integer and put it over 1 and make it into a fraction. 34/8 could be a fraction. That would be a rational number. I could even take a decimal like 3/4, and that would be a fraction. I'm going to go ahead and change 3/4 into a decimal as well, because it's one that we all know. It's 0.75. And this is a decimal that stops. I don't have anything after the 5. There's no dots after that to show it continues, which means that it terminates. So any fraction I can dream of, any integer, any whole number, any decimal that stops, any decimal that repeats. Our next vocabulary term is irrational numbers. Irrational numbers cannot be written as fractions. The decimals do not terminate or repeat. So we're pretty much looking at the opposite of rational numbers. So examples of an irrational number would be pi. We know pi is a number that goes on and on forever and doesn't stop, and there's no pattern to it. We could make our own decimal. I could have 3.4587291 ... So there's no pattern to that decimal. It doesn't repeat. It goes on forever. So I know that that could be an irrational number. You'll also see things like the square root of 3. So if it is a square root that I cannot take without a calculator, if the square root does not yield a whole number, then it will just be something that's irrational. To give you an idea of the real number system, all real numbers are either rational or irrational. And within rational numbers, we have integers. Integers are negative and positive whole numbers. And then inside that, if we want to be even more specific, we have whole numbers. Whole numbers are like 0, 1, 2, 3, 4, 5, and on up. Primarily, right now, we just want to be worried about rational numbers and irrational numbers. This is just to give you a sense of how the whole number system works. For number 1, we're going to be classifying. It says, are the following numbers rational or irrational, and why? So our first number, 15/8, that's definitely rational because we have a fraction. Square root of 36 I know is equal to 6, which is a whole number, and whole numbers are, of course, rational. So for my reason, I'm going to write whole number. For the next one, I have a decimal, but the decimal does terminate. There's nothing after the 3, so this is rational as well. And I'm going to write terminates. And just for kicks, we could take 8.3 and we could even make it into a fraction, just so you can remember how that's done. The 3 is in the tenths place, so it's 8 3/10. And then if I wanted to make that into an improper fraction, 8 times 10 is 80, plus 3 is 83, so this would be 83/10. My last number, -2, is an integer. So that's going to be rational as well. I can take any integer, put it over 1. Now I have a rational number. So it's rational because it's an integer. Now we'll check out the next row. So the first one's the square root of 51. So I have to figure out if that is a square root that I can actually take, or if it's one I need a calculator for because it's going to give me a decimal. So I need to know, is 51 a perfect square? Can I take the square root? So I could take the square root of 49. Square root of 49 is 7. I can take the square root of 64. That's 8. So this is going to be between those two. So this is going to be irrational. On the next one, I have a decimal that definitely is going on forever. It doesn't terminate. So it could be an irrational number. Let's check it out and see if there's a repeating pattern. I have the 657 that repeats over and over again. And so that means it's actually a rational number because the decimal repeats. On the last one, my decimal goes on and on forever again, but does it repeat? And I don't see any kind of repeating pattern here, and so it will be an irrational number. For example 2, we're going to convert the following decimal to a fraction. So on the previous page, I showed you how to take 8.3 and change that into a fraction. So that was a decimal that terminates. So let's kind of go over that process again. And we'll use one that's a little more difficult. So for terminates, I'm going to use 0.37. So the 7 is in the hundredths place. Remember, when we're going after the decimal, it's tenths, hundredths, thousandths, 10,000. So this is in the hundredths place. So I can make that 37 divided by 100, or 37 hundredths. So it's easy when it terminates. When it repeats, it's kind of a different story. So kind of a general rule for repeating decimals is that you can take that repeating pattern part of it. So let's see what repeats here. It looks like the 982 repeats. And so I have 3 and 982. And then your denominator, since I have 3 digit number here, I need to make my denominator 3 digits. And it's all going to be 9s, 999. So if I had something like 4.373737, I could make that 4, and the repeating part on this one is 37. And then again, if I have 2 digits here, I would need 2 9s, 3799s. So this is how we're going to convert decimals to fractions. Just a couple of quick examples. For example 3, we want to compare the following numbers using a less than, or a greater than, equals, or approximately equal to. I see I have a square root here, so I can either use a calculator or I can approximate it. So it's going to be easier for me most of the time to approximate. So I know that the square root of 4 is equal to 2, and I know that the square root of 9 is equal to 3. So the square root of 5 is going to be a lot closer to 4. I know it's going to be a little bit more than 2 then, maybe something like 2.2. So that tells me that the square root of 5 is going to be less than 2.9 repeating. And so I am going to use a less than sign. Remember, those look kind of like an L, and you could make that shape with your left hand. For number 4, we need to order the following numbers from least to greatest. So I find for me, ordering them on a number line, converting them all to decimals, and then ordering on a number line is going to really help me out. So here's my number line. And 2 1/4 is probably the easiest, one of the easiest to start with. That's going to be 2.25. So let's see, 13/4. What would that be? Let's go ahead and do the long division over here. 13 divided by 4. Let's see, inside of 13, there are 3 4s. 3 times 4 is 12. And then there's 1 left over. So this is 3 1/4, or 3.25. So last one, I've got to figure out a square root of 8. So I know that the square root of 9 equals 3. So this one's going to be close to 3. Square root of 8 will be close to 3, maybe like 2.8 or something. I'm just guessing. I just want to get something down so I know where to order them. So it looks like all my numbers fall between 2 and 4. So I'm going to put 0 here, 1, 2, 3, and 4. I could have made it smaller. I could have just put from 2 to 4 down, I guess, but I liked having the 0 on there. Let's see, 2 and 1/4 is going to go right here. That's about a quarter of the way between those two. 2.3, I need to remember that that's 2.30. So even though 3 looks like it'd be smaller than 25, because if I'm comparing 2 decimal places to 2 decimal places, it's actually bigger. So right next to it, to the right of it, I'm going to put my 2.3. And then my next biggest, let's see, what else do I have? I have 3.25. I'm going to just get that on there. 3.25 or 13/4. And then my last number I need to add is 2.8, approximately that square root of 8. So let's pick a different color for that one. So square root of 8 would be a little bit less than 3. So now that I have them all plotted on that number line, it's really easy to list them from least to greatest. So first is 2 and 1/4, and then 2.3, square root of 8, and last is 13/4. The last problem is asking us to tell which number doesn't belong and why. So I'm going to go through and use our vocabulary and just kind of examine each number and classify it. And hopefully from there, I'll have an idea which one doesn't belong. So my first one is a terminating decimal. So I know it's going to be rational. And I'll also write terminates, just making some notes for myself. 25.5 repeating is also rational. But this one's a repeating decimal. So those two are different, but they are both rational. They do have that in common. Square root of 26, I know is close to square root of 25. I can take the square root of 25 without a calculator. That's just 5. That's a whole number. But for the square root of 26, I'm going to get a decimal. That's not going to be a nice, even whole number. I would have to use a calculator. So I know this one will be irrational. So it looks like that could be the different one. Let's check our last one. The last number, negative 27 halves, is written as a fraction. So I know that that's rational. It's a fraction, and I know with the way 1/2 works, it would even be a terminating decimal if I was going to go ahead and divide that out. But it's clear that the square root of 26 is my outlier. So the square root of 26 doesn't belong. It's the only irrational number. Hopefully you have taken some notes on the number line, and so you have something to refer back to later. If something is not clear, please contact me or your teacher and get some help and some clarification on that. You should be ready, if you are using Canvas, to take the 1.01 module quiz now.